Right. So thank you, Daniela and David, for putting together this really nice memorial and symposium. So good afternoon, everyone. I'm Pratyusha, and I'm a graduate student in computer science and AI at MIT. And like everybody here today, I've been very lucky to have had some time that I shared with Roger over the last 4 years. And while I've known Roger for a much shorter time than most people here, I believe that that time has really shaped my life. Okay, so I was not sure what the right start to the talk would be, but perhaps right at the very beginning. So in my first semester of grad school, my advisor, Professor Antonio Torralba, who's sitting over there, told me about a possible project on understanding the calls of humpback whales. So my background was in robotics and machine learning, but I was always fascinated by evolution and loved biology. I thought that understanding the communication system of a species requires understanding the meaning of their sounds, but also understanding their goals, actions, aspects of environment that they choose to talk about. And it sounded like a problem that I could think of maybe as someone with a background in robotics. But of course, there was a huge problem. I did not know anything about whales. So 1 week later, Antonio and I, we went down to Daniela's office to understand what the project would entail, what the nature of the data would be. And we were going to hop on a call with Roger. And it was the first time I was going to speak to Roger. And to be honest, it was really intimidating. Yeah. Okay, thanks for the laughs. But okay, so like everybody here, I had heard of the record on the songs of the humpback whales, and had read about the tremendous single-handed impact he had on banning whaling across the world. Right? That's really huge for one person to have such a huge impact on so many living beings. It's something that is very hard to imagine. And that was also why I was really intimidated. How would he be, and so on. However, when he started speaking on the phone and told us stories of his first encounters with a whale and how it changed his life, I think even hearing those stories and the way he talked, it really changed something in us, right? And it really changed all of our lives. Soon after, we started reading Roger's book called Among Whales, and started listening to the data that Roger had shared with us on the recordings of the humpback whales. And my advisor and I, we started experimenting a little bit with it. While I had heard of the songs before, listening to Roger's story and reading it through his words, gave it a whole other meaning. Following that, we met for the first time after about a month, and it was like meeting a person, you already know, because you read his book, you realize, his first encounter with a whale when he's on a boat, and the whale slightly pushed the boat from under. But to be honest, nothing can really prepare you to meet Roger, right? He's, like Shane said, really tall, has a very good personality, and so deeply knowledgeable. He always has something very deep and insightful to say about anything, even things very far off from his field, right? At the same time, he's so humble, kind, and brilliant, right? And probably one of the best humans on the planet. The most striking thing about Roger to me was his equal, pure, and profound love for both science and conservation, and the rigor with which he did science, but contrasting that with his fierce yet really warm approach to conservation. Okay, so listening to the songs of the whales fills everybody with emotions that can hardly be put in words or explained, right? I think, however, knowing Roger has given it a completely different meaning. His love for the planet, real love for technology, and his approach to every person he meets with great kindness and pure, genuine love and curiosity for what they're doing, his love for science, and also the planet, and this never-ending drive, to find solutions to problems, in the oceans, but also outside. It's almost like a fire that he kind of lights in everybody just as he passes them by. Following that, meeting with Roger over Zoom every week, with his big, genuine, warm smile, very carefully constructed thoughts, and some very out-of-the-world ideas brought so much joy and taught me so much. And I wish I'd become as I grew up. So these things and many more memories with him will forever be etched in my mind. And I think knowing Roger changed how I see the world and how I want to do science and how I want to live my life. So today I was also asked to talk about the science I'm doing. And so the next portion of my talk will be trying to introduce some questions we've been looking at, and together with my advisors and collaborators at CETI and Roger have been studying, right? Okay, so just to kind of introduce what we've been doing, this is a scene from the movie Arrival. Right. So in this movie Arrival, an alien species visits the Earth and initiates a dialogue with humans. And they do this by producing sounds and by writing in this circular script on this really mysterious screen. So the movie follows a journey of a linguist where she interactively understands the communication system of the species while trying to teach them a little bit of our own. Communication is a key characteristic of intelligence. Being able to create an infinite number of messages by composing a finite set of sounds is a key trait that distinguishes human beings from other species. Understanding the communication system of another species and its complexity helps us understand their intelligence, cognition, their environment, and also their culture. Further, it also helps us understand how our own language might have evolved. But before we start to think about an alien communication system, there are millions of life forms on Earth with distinctive sounds and their own communication strategies. They've had their own physical and mental constraints and have evolved in unique ecosystems and societies. However, we know very little about their communication. So really the question that we've been trying to ask is, how do we decipher the communication of another species and possibly communicate back? So along with my wonderful advisors and the really incredible team of Project CETI, we study this question. And today I'm going to show you how maybe as computer scientists we could also contribute to this exciting project. So as many of you know, Project CETI is a non-for-profit organization with researchers from around the world with backgrounds in biology, cryptography, robotics, linguistics, AI, and so on. However, it's mainly based out of the country of Dominica in the Caribbean, which is also home to the sperm whales that we are studying. So at Project CETI, we want to first understand the communication of sperm whales, and then maybe think of how we could extend those ideas to other species. So sperm whales, as you know, are animals with the largest brains to have ever existed on the planet, and they've had it for 16 million years longer than us. They live in complex matriarchal societies with multi-generational bonds. The members of these families dive together, right? They coordinate their dives, they engage in extended periods of socialization, and even take turns babysitting each other's young ones, while coordinating in complete darkness, right? So when they coordinate, they also exchange these really long sequences of sounds with one another. So we know that they're communicating. What we don't know is how are they doing it, or what is it that they're saying. And that is what we've set out to find. So sperm whales sound something like this. And if the clicks were to be represented by vertical dashes, they would look something like this. So you can already see that the placement of the clicks is not random, but it's more structured. So the communication systems of sperm whales is believed to be made of these distinct sequences of clicks, and these groups of clicks are called codas. Past research on the EC1 clan in the Caribbean has identified 21 distinct coda types. A subset of these have been shown to contain information about the speaker and their clan identity. However, almost many other things about the sperm whale communication system, including questions about its structure and information carrying capacity, remain unknown. So, what makes this problem challenging? Sperm whales live in a completely different ecosystem and could produce and hear sounds very differently than us. Additionally, unlike the setting from arrival, the whales did not already come forth with the intent of teaching us their language. And we may not be able to interactively learn from them from the get-go. Therefore, to start, we want to largely be able to understand the communication system through a static data set containing recordings of their sounds and behavior. So what might the communication of sperm whales really look like? Is it like the crab and cuttlefish, where a few fixed gestures indicate current environmental factors? Or is it like the vervet monkeys, where a handful of sounds and their paired combinations are used to warn the rest of the tribe of predators and their locations? Or is it like humans? Capable. Capable of conveying a range of complex meanings and fairly abstract ideas. One of the key differentiators between human language and all known animal communication systems is the property called duality of patterning. It is how a base set of individually meaningless elements or phonemes get sequenced together to form words that can in turn be composed to generate an infinite space of complex meanings. For example, the sound b in the word banana does not mean anything by itself, right? But combined here with other meaningless sounds, it gives rise to the word banana, which is in turn combined with other similarly created words to convey fairly complex meanings, such as a joke like this one. So getting to the point of understanding the communication of sperm whales will require us to understand what features of their voice they control, what forms the smallest set of meaning-carrying units or the words of their communication, and how are these sounds sequenced together to exchange information in dialogue. And ultimately, what is it that they're communicating about? We have done some work on each of these questions, but today I will only talk about the first. So these are the visualizations of the codas we previously saw. And going into this project, we really did not know anything about whales and had no idea how to think of this system. However, we knew that until now, sperm whales were believed to produce only a small fixed set of coda types. And the contrast between the apparent simplicity of the system and the range of complex coordination behaviors it enables presented a fundamental mystery to researchers in the field. So the first thing we did was develop this visualization tool. So instead of plotting the clicks in time this way, let's plot them along two axes. On the x-axis, the position of the dot will represent the time the click was made at. And on the y-axis, how long after the first click in the coda the click was made. And let's do this also for the other clicks. If we do the same thing for all the whales in the conversation, each represented by different colors, we will see something like this. And now let us also connect the codas made by the same whale with lines. This will help us see how the different codas were made by a given whale and how they evolve in time. So we call this plotting style the exchange plot. Now, a 30-minute exchange between multiple whales looks like this. The exchange plot already highlights so much more variability in the sounds of the sperm whales that the visualization of the clicks and dashes just failed to show. Let's take a closer look at one of them. The exchange plot magnifies the structure of the codas across dialogues and also within a single coda at the very same time. Even though the clicks don't sound like music to us, when we plot them like this, they might start to look like music. They have different tempos and rhythms, and also just by looking at these plots, you can see that they can change one of the features without changing the other. Further, there are lots of other music-like features, like these ornaments that appear, and these crescendos that we call rubato. But how do we know if they're controlled or just random noise in the production of these sounds? Let's take the rubato, for example. If we take the sounds of a single whale, the changes between consecutive calls are sometimes nearly of the order of 100 milliseconds. Deducing what features of a sound are controlled is a question of not only what the individual sounds look like, but also how they affect the behavior or responses of another whale. We find that extremely delicate modulation of the duration of the codas is both perceived and imitated by responding whales in an exchange. So if this really was noise and imperceptible to a listener, how could it possibly be imitated? A more in-depth analysis of the sounds in the dataset showed that codas are not defined by a small fixed set of coda types, but instead formed a combinatorial coding system, where coda types can be explained by combinations of the following 4 features, each of which can be independently varied. The resulting set of individual sounds can represent 10 times more possible meanings than previously believed, showing that the sperm whale communication system is significantly more expressive than previously thought. So the existence of a combinatorial coding system at either the level of sounds or sound sequences or both is a prerequisite for duality of patterning. Combinatorial vocalization systems are exceedingly rare in nature. However, their use by sperm whales shows that they're not uniquely human and can arise from dramatically different physiological, ecological, and social pressures. These results open up the possibility that sperm whale communication system might perhaps provide a first example of that phenomenon in another species. Additionally, CETI is collecting a large amount of multisensory data in Dominica with a suite of different sensors, and this will allow us to use more powerful machine learning algorithms to analyze this data, and perhaps get us even closer to understanding the meaning of the sounds of the whales. Finally, hopefully the algorithms and approaches we develop in the course of this project will empower us to better understand the other species that we share the planet with and contribute to Roger's dream. Thank you.